Sorry for everyone for being late. I just was running a training session with a Columbia student who has a 2 Sigma hedge fund interview next week. So he's actually pretty good at lead code, but we just really need to sharpen him up the next few days. So I'm gonna do 3 sessions with him, all for free, all for content. It's dropping in my on my YouTube, but we're gonna get him right for his 2 Sigma interviews. And I know when Paul and them join, I'm gonna tell them about it because I know they're trying to work at hedge funds too. Yo, Ruben, what's good? Yeah, I'm putting this guy I know through a training session because he has a 2 Sigma interview coming up in the next few days. Dude, 2,900 a week or something is the salary. I was like, that's nuts. Yo, Paul. Yo, Paul, I have a video dropping tomorrow where I'm training a Columbia student. So a Columbia student reached out to me and he has a quant interview. He's a freshman. He has a quant interview on Wednesday. And pretty much I'm gonna spend the next 3 days helping him ramp up on lead code. He's actually really pretty good, but we just need to tighten some of the bolts. So 2,900 it was at 2 Sigma for 2,900 a month or 2,900 a week salary or something like that. I was like, that's nuts. But we just have to get him right for the interview though. He needs a little bit of prep. He just needs a little bit of prep. But yo, so I bought this GPT deep research feature for $200 a month, and we're gonna test it out. And I'm gonna show y'all like the reports it generates. How to be good at system design if I don't know anything about it. That's what you want me to ask it? I mean, I'll ask whatever y'all want. But I think I'm gonna start off with Python, Django, or I'll ask whatever y'all want. Yeah, it's actually pretty good. It sounded like a lot more when he said per week, but yeah, when I thought about it, it's like 150K. That's really good as a freshman for sure. 100%. That's a crazy salary. But if he works there as a new grad, it's gonna be way more than that. It's gonna be way more than that and it's just he's just an intern, right? They probably subsidize his housing and stuff. It's actually crazy. But 2 Sigma is a sick hedge fund. One sec, I'm just gonna grab some water. Yo, E, is that you? Recently, I'm learning Python with Django. Yeah, we're gonna dive deep into Python and Django. So I have this deep research feature. I'm gonna open up a new prompt, but we're gonna do this deep research feature. So what it's gonna do is, who here heard about this deep research feature? It's actually pretty crazy. This feature is nuts. I'm gonna move this a bit to the side. Yo, E, are you a user? I can't tell who user is. Oh, okay, someone else. Barrier to QI so much. Okay. We're gonna yeah, but yo, user. Essentially, what we're gonna do today is we're gonna try out this deep research feature. So I want to cover a few topics. We're gonna deep research Python, then we're gonna deep research Django, then we're gonna deep research MongoDB. Because that's like a common backend tech stack, even at a lot of startups. Like Python is big for so I just want to learn more about Python through this deep research thing, and let's all study it. So we click this deep research. And we only get 100 queries per month, so we can't spam it. But we're gonna do deep research. So, how should I prompt it? Be like, I kind of want to get an understanding of Python across the board, like end to end, but also go deep into some of the other things, like how is it being transpiled or not transpiled, like it doesn't get compiled, right? So like how does it run, and like super deep into that. And yeah, I want to get a very deep understanding of Python. To know everything about the language internally, and also want some breath when it comes to the it's interpreted, right? I want to sorry, it's blanking out. Like it's interpreted, so trying to figure out like how it all works under the hood. I mean, like deep. Like MyPy, pip. What else? What else do people? What poetry, etc. So So I want to get a very deep understanding of Python. I use it every day, but want to know everything about the language internally, and also want some breadth when it comes to Python ecosystem. So that's to tailor the research effectively. Could you clarify, do we want an internal focus? Are you looking for details in Python's memory management, garbage collection, interpreter internals, or something else? Ecosystem breadth. Should I just cover popular tools like MyPy, pip, poetry, or a broader set of testing frameworks? Should I focus on advanced topics only, or do you want a structured progression from fundamentals to internals? Bro, I want all of this. What is he talking about? If I'm gonna pay $200 a month, like give me everything. Yeah. I want all of that. Okay. Okay, now it's beginning to research. Isn't this crazy? So this could take up to 5 to 30 minutes, but we can see what it's doing, what it's research, like what it's finding in its research, and the sources that it's using. So let's see how it works, and then we'll dive into some other stuff. What do y'all think so far? This could take 5 to 30 minutes. Yeah, because it's trying to improve the output, right? It's trained like that because it wants you to get it wants to have a good output. So it's try to do like a single shot. It's trying to basically it's trying to build context to feed into the model to have a better answer. I think it makes the outputs better. I don't know. What do you think? Okay. Let's see. Why, user, do you like that or not? Yeah, they're really pushing towards these more they're really pushing to these more like multi shot reasoning capabilities. So when you look at something like O1, which is a reasoning model, it has like an internal chain of thought. So whenever you ask it a question, it tries to break it down into steps to solve that question, and then it would like there's an internal chain of thought. That's why they perform so well. And this thing is even to an extreme where it's internal chain of thought. Yo, what's up? Who's putting all the emojis? That's sick. But essentially, this new deep research has an internal chain of thought, but it's like to an extreme. It literally thinks for 5 to 30 minutes. You could see that it's already compiled 16, 17 sources. And we're going to read through these sources real quick. So let's look at how it breaks down, how it's building this report. So we're trying to build a comprehensive guide to Python internals and ecosystems. So it's talking to itself. I'm gathering internal and ecosystem details, highlighting key concepts like memory management, bytecode execution, and Python's Py, progressing through each topic methodically. I'm mapping out Python's ecosystem. Yeah, you could. I bet a lot of hedge funds are using this for market research. So I'm mapping out Python's ecosystem covering package management, type checking, testing frameworks, web frameworks, scientific computing, async programming, and security best practices. I'm compiling recommended Python books, courses, and online resources to support learning internal mechanics and ecosystems, ensuring citations and structured formatting for clarity and accessibility. So look, it starts looking into the different websites. It's reading into DataCamp. I'm checking out the content around line 200 to see if anything is relevant worth noting. So it's giving you the link, right? Yo, thanks for coming in. I appreciate you joining and watching my stuff. Appreciate it, Dice. Tomorrow, I'm dropping a video where I'm training up a freshman from Columbia, who has an interview at 2 Sigma, the hedge fund, in the next week. So I have 3 sessions with him over the next few days, and we're gonna get him right for his interview. It's gonna be a 6 series, and yeah. I hope you all like it. I'm going to try to do more with a bunch of students trying to get into Fang and whatever. Okay. I'm recognizing that CPython uses a hybrid of reference counting and generational garbage collection, while PyPy employs contiguous garbage collection or continuous garbage removing garbage. Wow. No, you can't even type. I mean, like, typing won't do anything. And you can't send it because it's thinking. It's disabled. But, like, you could see it's just like, look at this. It just it's thinking. Isn't that crazy? Okay, where are we? It's talking about, why is it talking about garbage collection? Why is it focusing on that first? So just-in-time compiler. So the thing is, once I get this research report, and hopefully it has a lot of breadth, I'll just use GPT to like investigate some of the topics that I'm interested in a little bit deeper. Search for the difference between CPython, PyPy, and I'm working through Python implementation. CPython compiles to bytecode. Jython runs to JVM. PyPy uses JIT and micro. So there's like 4 different types of Python implementations. Yo, I'm down. Which election? 2016, 2020, or 2024? Paul, I'm down, man. But GPT is so annoying because it always tries to be so politically correct. You try to ask it something and it's just like, oh, I don't want to talk about that. Politics. Like, there's a politics filter. Yo, Alpha in the building. Yo, who knew that Python had 4 different implementations? I didn't know that. Did y'all know that? PyPy stands out with cross-platform compatibility. Okay, at the same time, we're gonna GPT some things on the side. Mod, what's good? We're going deep into Python today. Yo, Caesar, look at this. It's like I just gave it this little prompt and it's been thinking for like 8 minutes now. So we're gonna see the full report. So now it's talking about how Jython translates to Python to Java bytecode for the JVM. Okay, now it's talking about Python's relationship with C. Consider medium, pubnub for access, indicate. I don't even know what it's talking about here. So it's talking about the global lock interpreter. Yeah, it's been thinking for so long. And then you could see the sources it's pulling. Like it's reading different websites. It's reading the literally PyPy org, right? So it's read 41 sources so far and it just keeps shooting it out. And then it's like thinking on it. And it's building, at the end it's gonna spit me like a full research, basically a whole research report. It's like you have somebody like an assistant. You're like, yo, can you go research this thing for me? And then they come back with it. And they look through 50 different websites. Wouldn't that be sick? That's literally what it's doing. But now I'm just like looking over what it's actually looking into. Why is it digging into PyPy and Jython? Yeah, it's pretty nuts. It's called deep research and it requires, you need to pay $200 a month for it. Okay, it's done. Okay, let's look at this report. Let's literally look at this report. So, Mastering Python, a comprehensive guide to internals and the whole ecosystem. So, y'all, like, what's it called? Help me understand this stuff because this is going to get really deep. So, look at the report it gave us. So, we're just going to read this quick. It literally gave us an end-to-end, and we should understand Python end-to-end after reading this. And I tried to make it deeper than it should. Let's see. Okay, we're going to read this from top to bottom. Then we're going to move on to Django. And hopefully we all learn something. Even if you don't know Python, or don't actually work with Python, you'll still probably learn something that you might be able to apply to whatever programming language you're using. So Python is a powerful and multifaceted language. To truly master Python, an experienced developer must delve into both the internals. So we're diving deep into the internals of how the language works under the hood and the rich Python ecosystem, the tools, libraries, and best practices. This guide is structured from fundamental concepts to advanced topics, covering everything from memory management and bytecode execution to frameworks, to web frameworks and security. Along the way, we include recommendations for further reading, books, courses, documentations, and highlight emerging trends and tools that can elevate your Python development. Internals. So understanding Python internals will deepen your intuition for how Python code executes and how to write more efficient and effective programs. We will explore memory management, interpreter implementations, the Python virtual machine, and bytecode, the GIL, which is the global interpreter lock, and the compilation process, and advanced metaprogramming techniques. Yo, just this section is gonna be crazy. And it has like links to all the sources, so it's, it's not making stuff up, and it points like right to it. Look at this: Python garbage collection key concepts. So memory management. I'll run system design research on it as well. Yeah, Markel is sick. I'll show y'all. I have this video I just dropped. Yeah, system design one is gonna be sick. I'm gonna drop that as its own video, probably. But yo, if y'all want to see it, I made it do a deep research on data structures and algorithms. So check that out. So Python, particularly Cython, the reference implementation, uses a combined memory management system strategy. Reference counting for immediate garbage collection, supplemented by cyclic garbage collector to catch reference cycles. Every Python object has a reference count that increments when a reference to the object is created and decrements when the references are removed. When the count hits 0, the memory is freed immediately. This approach is simple and effective but cannot reclaim objects that reference each other in a cycle. I see. So it's just talking about how do we know how to garbage collect an item, right? So basically we just count the number of references to that object. But that makes sense that it can't catch cycles. So how does it do that? To handle cyclical references, Cython periodically runs a generational garbage collector that detects reference cycles and frees those objects. Nice. The garbage collector categorizes objects by generation. Newer objects are checked more often than older ones to optimize performance. Under the observation that most objects die young. In practice, this means that short-lived objects are quickly collected while long-lived objects are scanned less frequently. I see. Alpha, what language did you have to write it in? The garbage collector. Was it in C? Or assembly or something? It's important to know that other Python implementations have different garbage collection strategies. For example, MyPy or PyPy. Okay, so it's just talking about garbage collection. The key takeaway is that while the concept of automatic memory is common, the mechanics can differ. So best practices. Generally, you don't need to manually manage memory in Python. The garbage collector does that automatically. But it's good to avoid creating reference cycles when possible and to release large objects. Tools like memory profilers can help identify leaks. If memory is a critical issue, consider alternative implementations or libraries, for example, PyPy's. Okay, cool. Yeah, it just talks about garbage collection. I mean, why is garbage why I wonder why I brought that up right away. I guess, yeah, you don't want your program to just take up a crap ton of memory though, right? What's ARC, MRC, and GC? So garbage collection is crucial in programming languages for several reasons. Okay. I could probably just use O1 for that query. Right? Let's use O3 mini or O1. I'll send you the response to this. Free web scrape feature. This search. No, search is different than deep research. Search, what it does is it just pretty much it's not really thinking or using reasoning. You know what I mean? Okay, where are we? Or deep research against web scrape. I mean, yeah, just this search or web scrape. I don't know what you mean. Let's see. So now it's talking about interpreter internals, Python, PyPy, and other implementations. See, this already gives like a pretty detailed report on the difference. I can share this. Oh, it's way too much text. Can you see that? I'm also gonna share this. If y'all want to read along. Yo, and let me know what it says. Can you summarize it in the Can you summarize it? Okay, Python, PyPy, and other. Python is defined by a language specification. Yo, Alpha, this is not mine. I'm using a friend's. And we're very limited on queries. It only limits us to like 100 queries, and he's only letting me use about like 10. I paid him like $20. That's why I can't just research everything that y'all want to see, because I only have like 10 queries. Python, PyPy. This thing is very limited. Like, it doesn't let you run, for the deep research, it only lets you run 100 per month. So now we're talking about interpreter. Python is defined by a language specification. There are multiple interpreter implementations. The most common is Python, written in C, which is a default interpreter you get from python.org. So most people are using the Python interpreter. Python compiles your Python source code into bytecode and then executes that bytecode on a Python virtual machine, a stack-based interpreter loop. This is why Python is often called an interpreted language, but note that it does have a compilation step. It's $200 per month. Yo, Alpha, do you use Python at work? 200 USD. Yeah, and the reports are actually, yeah, we'll see by the end of it, Alpha. Let me know if you think that each of these reports are actually worth $2. Right. What do y'all think so far? Beyond Python, there are other important Python implementations. PyPy, implementations of Python in Python, more precisely in a subset with a focus on speed via just-in-time compiler. PyPy generates machine code at runtime for hot code paths, often resulting in significant speed-ups for long-running programs. Uses PyPy is known to improve performance on do its startup. Okay, just talking about the different Python implementations. Okay, I don't know if I care about that too hard. All these implementations execute the Python language, but with different under-the-hood approaches. Python remains the reference in most widely used. If you downloaded Python, you're using Python. For most, but knowing, okay. I don't know. I've never used these other versions of Python. I have a question. Does syntax change? Between different Python implementations? I see. I think I'm getting we'll get the live subscriber count. We running it up. Maybe I'll run this till we get to 8K. No, I was kidding. I don't know if I can do that tonight. That might be by the end of the weekend thing. VLZ. What's good? No, I'm gonna run it on this side. Yo, low. Always, man. Always. No, the syntax of the Python language does not change between different implementations. Python, PyPy are all of these implementations aim to follow the official Python language specification. However, the built-in libraries performance and can vary. Okay. Can you? I needed to give us a. Let's get it to generate to some code snippets of what Python looks like. Can you give me deeper insight into the Python source code? Damn, they have a whole Python source code. What? What? It's all written in C or what? Okay. Okay. I have a friend who works on compilers, so he probably will understand this way better than me. I don't even know none of this. Okay, there's basically an interpreter. Can you explain what's the Odin project? Can you explain an interpreter to a first year student? Imagine a friend who's only, every time you say a sentence in English, your friend can't understand it until someone interprets it into Spanish right away. Oh, really? Wow, that's sick. Juber was good. Maybe I'll go through that. Nah, I didn't kind of do this stuff for a living. I mean, the best way to get good at any of this stuff is just work in the industry. You'll get good really fast. Tom, what's good? We're doing deep dive into Python. Trying to understand what I'm trying to get it to tell me what an interpreter is to a layman. It translates each piece of code into actions or machine instructions on the fly, so the computer knows what to do immediately. If you change something in your code and run it, the interpreter will retranslate that code every time you run it. Yeah, I won't learn anything. So it reads the next line. Tom, not really. I watch basketball though. Executes the instruction. If the code is valid, the interpreter performs the action on the screen without creating a separate file. Okay. Okay, this makes sense. I like the Suns because I like KD. So compiler translates all your code in advance into a separate machine code. So you run that translate compiled program later. Translator does it step by step and immediately executes each statement. It doesn't include a separate file, runs the code as it goes. A compiler is like a translator who writes out a whole speech in a new language before anyone says it. Okay, that makes a lot of sense. Like, yo, it's been a while since I touched these subjects. So does Python translate to C or bytecode? In standard, your Python source is first compiled into Python specific bytecode, and the bytecode is interpreted by the CPython virtual machine. Okay. First that line by line and who yep, 100 and 120k is pretty good. It's pretty good for entry level. Even for like intermediate, that's good. But Bay Area is very expensive. But I think for new grad, that's good. Tom, like, how long have you been living here? Or like, are you a new grad? Who runs it? Runs it on the virtual machine. So okay, this is what's happening. So we have our CPython. This is CPython. So we have our CPython. This is code. This is our interpreter. So when we write Python code, we get Python code. Yo, Paul, I'm gonna dig into this. into that. We're gonna do a ton of deep research, but pretend we have Python code right here, right? We write Python code. What we have this Python code that's gonna, I think it's gonna read line by line. It's a program in itself, but it's gonna read line by line your Python code, and take every single line. Yeah, we're gonna dive deep into MongoDB as well. But essentially, it's gonna read it line by line. Maybe I'll skip to MongoDB. But essentially, it reads it line by line and does it pass it to the. And then we have another thing called. It converts it, reads it. It converts it to bytes. And then finally, we have our what did they call it? Virtual machine. Yeah, exactly. Everything's easy until you have to until you need it optimal. And then what? And then this runs on our. And what does the virtual machine run? Does this run on our actual computer? Like this runs on our PC? I mean, it all runs in our PC, but I'm just trying to visualize this out a bit. Okay. So yeah, we have the Python. It's reading line by line. Okay, so it does more than that. Parsing CPython reads your entire Python source, parses it, and then compiles. Yeah, but I see. Yeah, we don't really need to. I just want to get like a high. I just want to get like a high level visualization of it, so I can kind of like have a visualization of how it works in my head, but I don't want to go too deep into it. You know what I mean? It's like maybe that would be for another day. How is this? Okay, the CPython compiler and VM are in the same program. Okay. Okay. Damn, okay, I'm gonna check that out. So overall flow. So we get our source. That turns into the bytecode. So we take our source, we pass it through the parser and compiler in CPython. We get bytecode and we run that bytecode on the VM. Okay. Okay, it's saying that this is actually pretty accurate, but the Python and virtual machine runs in the same thing. Something like this. Something like this. So this is its own executable code, and it runs your Python code. Yeah. Okay, that's all we need to know about that Python, bro. Okay, I want to refresh myself on the virtual machine. Talk about the virtual machine. You don't really need masters these days. It depends. Yeah. Python script. Okay, the VM reads it. Okay. Okay, we get code like this. Okay, see, this is what I wanted to see. I wanted to see real examples. So, okay, we take this code like this, and then we pop that into the, and then it turns it into bytecode. Okay, where's this bytecode ran? Okay. Okay. Okay, I think we just need... Yo, Caesar, I think for your test case too, you'll need to feed it in a lot of... It needs to be able to read your code base though. But we're not even using deep research now. We're just like, because we're just kind of researching away from it a bit. Because I'm trying to understand more about the virtual machine. Can you explain more about virtual machines and how it runs code? CPU architectures. So virtual machine is a language runtime. So it defines its own set of instructions instead of targeting a specific physical CPU. Okay, that makes sense. It's like an emulator. Then the VM then runs on any real machine underneath. Why does this help with portability? Without a VM approach, you'd compile your code directly into CPU-specific machine code. For example, you'd have to choose instructions for x86 or ARM. If you want to run another architecture, you'd need to recompile or distribute separate binaries. With a VM approach, your program is turned into a platform-independent bytecode. The same bytecode runs on any machine that has a VM implementation. If you have a VM compiled for x86, Linux, and one. Okay. Who writes this VM then? Who writes the VM or who writes the VM? But we're getting deep into like some of the Python, how this thing is actually gonna run. Move up I'm gonna stand up a bit. So 2 sec. Gonna stand. Yeah, I want to do a master's too. Alpha, I think you would enjoy it. I feel like you really like studying. Okay, whatever. We know what a VM is. Let's okay. Whatever. Let's move on to the next thing. Py. So these are all just interpreters. Oh, we have Python that compiles Python code to Java bytecode. Wow. So all these implementations execute the Python language, but with different under the hood approaches. Okay. Yeah, we read that. Okay. Okay, actually, I don't even know why I did my own research there when it just talks about it right here. Dude, it gets deep. So it talks a bit about internals like the global lock interpreter. What's a global lock interpreter? Yeah, I've seen that before. I actually wanted to join that too. Paul says it's actually really hard. Atlantic. I've been programming probably like 10 years. But I only started in college. I'm like mid 20s. But almost leaving my mid 20s. Oh, they're finally removing that? You're Mahdi, what's good? I don't want to leak my birthday on the stream because my birthday is my password for some of my bank accounts. I'm just kidding. Let's see. Only... So we have a global lock interpreter. It's a mutual exclusion lock that allows only one thread to execute Python bytecode at a time in a single process. So Python has one single process. This means that if you have multiple threads in your program, only one thread can be running Python code on the CPU at a given moment. The GIL ensures thread safety for Python objects, simplifying memory management across access in a multi-threaded context. That's why when people say people say Python is not really multi-threaded because it's just all the different threads are just sharing the same CPU. Abraham, how's your like lead coding skills and stuff? So because of the GIL, Python threads are not able to execute in parallel on multiple cores for CPU bound tasks. If you have a CPU intensive computation, throwing threads at it will not make it faster. In fact, it will actually make it slower due to the overhead of context switching. This is one thing people should know when they're using Python. If you have a CPU bound task, multi-threading it will make it actually slower. If it's like IO bound, like it's making API calls or something, then multi-threading it might make it faster. Because while it's waiting for the response, it could go do something else. So yeah, that's kind of what I said there. So there are a few ways to bypass limitations. Okay, there's the multiprocessing library. I don't even know. I think you can get by without math, but you need to know like simple additions and stuff. You need to know you need to be good with numbers and stuff. Wow, good job, man. 18 to 2000 is pretty high. Abraham. Yo, you got this. Let me know if you want to do a mock interview or something. So the GIL has been a subject of debate for years because it simplifies CPython's implementation at the cost of multi-core CPU parallelism. There are efforts to remove or reduce GIL's impact. In fact, an upcoming change in Python's future is making the GIL optional. Wow, get a full multi-threaded experience. Wow, that guy's a beast. Yeah, Abraham, join the Discord, but we'll have to record it for content if that's cool with you. It could just be like voice chat or something. And you won't even need to say your name or nothing. But I need to get a vid out of it for sure. Bro, they won't even... It's all good, man. I embarrass myself all the time on my videos. How Python compiles and executes code. Bro, I don't care about this anymore. So Python handles introspection and metaprogramming. Introspection is the ability of a program to examine the type or properties of objects at runtime. And metaprogramming means writing code that manipulates code, such as dynamically creating classes or functions. In Python, everything is an object. Classes, functions, modules, even types themselves. This means you can inspect these objects and often modify them. So what's introspection again? Oh, wow. All languages have this, right? Have this feature of introspection. In summary, Python's metaprogramming capabilities allow you to write code that manipulates code. This can lead to very elegant solutions for certain problems. For example, decorators that reduce boilerplates, ORMs that auto-create classes and database tables, or serialization libraries that can iterate over object attributes with. Another example, the data class module uses metaprogramming to automatically create init and other methods based on. Wow. Okay, we dove a little bit deep into actual Python. We learned a bit about the interpreter. We learned about the global interpreter lock. And we learned about metaprogramming. Does everyone get what metaprogramming and introspection is? Who has heard of that? Sec. Just tell me to pull up. I'm gonna get ChatGPT to talk for me for a bit.
Hey, it's great to meet you. How's your day going? I'm really looking forward to working on some cool stuff together.
Hey, can you explain to me metaprogramming and introspection in Python?
Sure. Metaprogramming in Python involves writing code that manipulates other code. This can be done at runtime, allowing you to modify or dynamically generate classes, functions, and objects. Introspection, on the other hand, is the ability of a program to examine the type or properties of an object at runtime. In Python, introspection allows you to use functions like type, ID, or isInstance to inspect objects. Would you like some examples?
Yeah, isn't that common in most programming languages these days, though? Or what are some programming languages not true?
Yes, metaprogramming and introspection are quite common in many modern programming languages. For instance, languages like Java, C#, and Ruby also support these features. However, there are languages like C and older versions of C++ that have limited introspection capabilities and don't support metaprogramming in the same way. These languages are more static and lack the dynamic runtime features seen in Python or Ruby.
Wait, can you say that again? I was looking at my phone.
Sure. Metaprogramming and introspection are common in many modern languages like Java, C#, and Ruby. However, languages like C and older versions of C++ have limited introspection and don't support metaprogramming in the same way. They're more static and lack dynamic runtime features.
Can you explain some of those features that they have in Python but you can't do in C or C++?
Certainly. In Python, metaprogramming allows for dynamic modifications at runtime, such as 1. Dynamic typing and reflection. Python objects can be examined and modified at runtime, allowing you to inspect and change attributes and methods dynamically. 2. Metaclasses. These allow you to customize class creation, modifying how classes behave by defining special methods like _new, decorators. These provide a way to modify the behavior of functions or classes. For instance, you can add logging, enforce access control, or measure performance. In contrast, C and C++ are more static, lacking these runtime dynamic features.
Okay. Let me. Cool. That's what metaprogramming and introspection is, guys. Introspection is like is the ability to examine the type of properties of objects at runtime, and metaprogramming, it means like writing code that manipulates more code. That's kind of sick. Okay, finally, let's dive deep into higher level stuff like Python ecosystem. So beyond the core language, Python's ecosystem includes a vast array of tools and libraries that support development. An experienced Python user should be proficient not only in writing Python code, but in managing packages and environments, using development tools like linters, and leveraging testing frameworks. Yeah, I think this is key right here. So, I think to really be good at whatever language you are using, you should really understand how to manage packages and environments in that language, and actually like a little bit of how it runs on the machine. And then other things like development tools, like how do you have linters and formatters and type checkers on them? What are the different ways you can write tests and dive deep into the testing frameworks? And then also a bunch of the different more common libraries. I think that's like that's first focus on just using that language, but then if you really want to master that language, you got to dive deeper into this stuff. And that's kind of what we're trying to do today. And this might, yeah, Alpha, I'm going to do more of these. I'm going to do more streams like this, and we're going to do a bunch of deep research. I'm going to deep research whatever y'all want. So package management. But I use Python at work. That's why I'm trying to dive deep into it a bit. But these concepts are shared across multiple languages. Like Node, instead of using pip or poetry, use npm or yarn, right? Oh, I didn't know that. So this is the default package manager installer. With pip, you fetch packages from the Python package index. Pip is straightforward and works well with pure Python packages and many C extensions. It installs packages into your Python environment, and you can install dependency trees as well. It will fetch required dependencies automatically. Pip is simple and ubiquitous. Most projects use pip and requirements.txt to manage dependencies. I think poetry is way better than pip. Pip requirements.txt sucks, but poetry is way more beautiful. Poetry looks a lot like npm or yarn, but requirements.txt, just a raw format, is just ugly to me. Yeah, exactly. Lo, I hate pip and VNV. Like poetry is beautiful. Poetry is so simple. Yeah, Lo, you should try it out. Getting cold. So Poetry is a newer high level tool that handles dependency management and packaging in one coherent workflow. It uses a PyProject toml to specify dependencies, and then you can lock them. See, it's a lot like if you're used to NPM or you're used to Yarn, it's very similar. So Poetry also can build and publish packages. Essentially, Poetry aims to simplify Python projects setup by managing virtual environments automatically and precisely tracking dependencies. Yeah, like Poetry also manages your virtual environment, which is crazy. Poetry is really good, yo. Okay, and it's more popular. Shabaj, when is that? Is that today? I don't know if I can make it, man. Cause I'm streaming. Oh, okay. You sent it where? Yeah, I think I know where you sent it. Yeah, I remember. So yeah, this was a pretty annoying approach before, which was pip virtual environment and then the setup tools. Okay, Conda. So Conda is both a package manager and an environment manager, and it's not limited to Python. Can you give an overview between pip, Poetry, and Conda?
Certainly. Here's an overview of pip, Poetry, and Conda. Pip is Python's default package manager. It installs packages from the Python package index, PyPI, and is widely used for managing dependencies in Python projects. Poetry is a tool for dependency management and packaging in Python. It simplifies the process of creating and managing virtual environments, dependencies, and packaging projects. Conda is a cross-platform package manager that supports multiple languages, including Python. It's particularly popular in data science for managing dependencies and environments, offering pre-built packages and environment management. Each tool has its strengths depending on your project's needs.
Cool. Can you dive a little bit deeper into Conda? Like, why it's not just a regular package manager, right?
That's right. Conda is more than just a regular package manager. It's a powerful tool for managing both packages and environments, which makes it especially popular in the data science community. Here's why. 1. Cross-language support. Unlike pip, which is specific to Python, Conda can manage packages for multiple languages like R, Ruby, and more. This makes it versatile for projects involving different technologies. 2. Environment management. Conda excels at creating isolated environments, each with its own set of dependencies. This is crucial in data science for maintaining reproducibility and avoiding conflicts between different projects. 3. Binary packages. Conda distributes precompiled binaries, which means you don't need to compile packages from source. This is particularly useful.
Doesn't Conda you manage Conda using a UI? I forget. Or you download it and you use a UI to manage your Conda folders and stuff and environments.
Yes, you can manage Conda using a UI. Anaconda Navigator is a popular graphical interface that comes with Anaconda distribution. It allows you to easily manage packages, environments, and even launch applications without using the command line.
Is it basically like a terminal emulator?
Anaconda Navigator isn't exactly a terminal emulator. Instead, it's a standalone graphical interface that simplifies tasks like creating and managing environments, installing packages, and launching applications. It provides a user-friendly way to handle these tasks without needing to use the command line.
Okay, we know the different. So in summary, pip is a lightweight standard. Poetry is convenient all in one. And conda is a heavyweight for powerful solution, especially. Okay. Okay. Okay, always use virtual environments. That makes sense. To avoid dependency clashes between projects. Pin your versions. Consider tools like pip tools to manage pin dependencies. Keep an eye on the transition to as a single source of truth for a package. Okay, cool. Yeah, package management is important because every time you have a piece of software, you're gonna want to pull in some third party code to do stuff for you. You don't want to write everything from scratch, right? And yeah, essentially once you pull that in, now you just have a bunch of different libraries and you could just start writing code. Now, let's talk about MyPy. So Python is dynamically typed, but over the past several years, there's been a strong movement towards optional static typing using type hints. So these are the two biggest ways for type checking. Who heard of MyPy and Pyrite? Who heard of these? MyPy and Pyrite. We use it a lot. A lot of big companies use it, like MyPy and Pyrite. It basically it types checks your code. It's like types. It's essentially like TypeScript, but for Python. I'll get GPT to explain it here. Can you explain what MyPy and Pyrite is for, and why it's useful for development, or just in general why it's useful?
Sure. MyPy and Pyrite are tools for static type checking in Python. They help you catch type errors and ensure type consistency in your code before runtime. MyPy. This tool checks your code against type annotations you provide, helping to catch bugs early and improve code quality. Pyrite. Developed by Microsoft, it's another static type checker that also offers features like type inference and performance optimization. Using these tools is useful because they help you catch errors early, improving code reliability, make your codebase easier to understand and maintain, provide better support for IDE features like auto-completion and refactoring.
Do things like PyCharm or VS Code use the MyPy output to help with auto completions and all the IDE features, or does it run its own? Does it have like its own language server or something?
Yes, IDEs like PyCharm and VS Code can use MyPy for static type checking. They integrate MyPy's output to provide features like auto-completion, error highlighting, and code navigation. In VS Code, the Python extension uses Pyrite as its default language server, which also provides rich IDE features. PyCharm, on the other hand, has its own type inference and checking system, but can also integrate with MyPy for enhanced type checking.
Paul, does that everything make sense now? Why you need Pyrite, or what MyPy and Pyrite do? Yo, one thing about MyPy is it's really, really slow. So using static type checkers in Python is now considered a best practice for large or critical projects. Even the Python standard library is progressively being typed in stub files. Type checking helps catch bugs early and improve readability and maintainability. Okay, wait, I never did Pywrite too much. Is it fast? Like, it's done CLI. I need. It also forms core of many editors. In practice, MyPy and Pywrite are mostly compatible in which they accept. Okay. I've never used Pywrite. Harold in the building. So how to integrate. You can gradually introduce type hints and use MyPy to check them. For example, add a MyPy init configuration to a project and perhaps run MyPy. Yo, GMT! What's good? We're diving deep into Python. Okay. So these are some other alternatives. Pyre by Facebook and PyType by Google. Linters like Pylint and Flake8 have some overlap but are not. Okay, cool. Now, okay, we know how to write code. We know how to execute code on the virtual machine. And now we have our code. Now we need to talk about running tests or like testing frameworks. Testing is vital for writing reliable software. Python comes with built-in XUnit style framework unit tests. And the ecosystem provides more powerful frameworks like PyTest and property-based testing with hypothesis. Unit tests. This is built-in framework. It requires you to write test classes inheriting from the unit test, and then you use special assertion methods inspired by Java's JUnit. So it's very familiar if you've used XUnit frameworks. So unit test is included in the standard Python library. It provides the basic test structure and discovery. It's a bit more verbose. It lacks some of the conveniences of newer frameworks. So yeah, unit test is just one of the test runners. But it's saying PyTest has become the de facto standard for Python testing because of its simplicity and power. With PyTest, you can write your test as simple functions. No classes needed, but though you can still group it into if you like. PyTest has a very powerful test discovery. So you have to write functions with test underscore in files, and then it will find them and write them and run them. So its assertions are plain assert statements. So PyTest supports fixtures. Powerful plugins and many conveniences like parameterizing, testing, and skipping. Yeah, PyTest adds So most projects pick PyTest unless you have a strong reason not to. And even PyTest is like a superset. It could run unit test. Can you give an overview on PyTest?
Absolutely. PyTest is a popular testing framework for Python. It's designed to be simple and scalable, making it easy to write and run tests. Here are some key features. Simple syntax. PyTest uses simple, easy-to-read syntax. You can write tests as functions using assert statements. Fixtures. It provides a powerful fixture mechanism to set up test preconditions and clean up after tests, promoting code reuse and modularity. Plugins. PyTest has a robust plugin system, allowing you to extend its functionality, for example adding code coverage or parallel execution. Test discovery. It automatically discovers tests in your project, making it easy to organize and run them. PyTest is versatile and can be used for both small projects and large complex applications.
Sorry, what about PyTest or stubbing? Is that provided in the PyTest framework, or you have to import other libraries for that?
PyTest itself doesn't provide built-in mocking or stubbing capabilities. Instead, it integrates well with external libraries like Unitest Mock or PyTest Mock. Unitest Mock. This is a standard library module for creating mock objects and stubbing out dependencies. PyTest Mock. This is a plugin that provides a more convenient way to use Unitest Mock with PyTest. These tools help you isolate parts of your code during testing, making it easier to test individual components independently.
I see, I see. I've never heard of this hypothesis, sorry. You specify properties and let the hypothesis generate many random test cases to try to falsify those properties. Wow, what the heck? I never heard of this hypothesis. That actually sounds pretty powerful. I wonder if they're gonna have like LLM based ones soon. That'd be crazy. So use unit tests if you need the standard library or prefer class based tests, but be aware it's bit boilerplate heavy. PyTest for most needs it's more flexible and concise. It supports complex testing needs via plugins like PyTest Django. Okay, it has some plugins. It has way better readability. So we need a good mix of unit test, integration test, and if applicable end-to-end tests. Use test doubles like mocks and fakes when necessary. Unit test, mock. Keep test deterministic. And then also Consider measuring coverage with tools like coverage.py to see which parts of your code are not tested, and use continuous integration to run tests on each commit. I always say contiguous instead of continuous because I've just been spamming LeetCode. Let's see. So checking out I got a banger video dropping tomorrow with that guy I'm helping prep for the hedge fund. It's gonna go crazy. Book Fluent Python. Why is it cringe? Which dude? Oh, he's applying for a regular SWE role at 2 Sigma or Quant. I don't know. So Python is a top choice for web development with several frameworks available. Richet, what's good? I'm trying to get to staff. I want to get to staff soon. But I want to start my own company and stuff too. So probably like get to staff, learn as much as possible, make some money, and then try to start a company or something. I don't know. I just enjoy software in general. So just doing anything related to coding, doing projects and stuff, and try to make a living from just literally writing code would be sick. I mean, I'm already making a living from just writing code, but just continue to do that. And maybe on my own terms as well at some point. So Python is a top choice for web development with several... It's a lot of money. But I don't know. I'm actually not even really in it for the money. I do like money, but I also like... I also really enjoy it. And I enjoy making money doing it, for sure. So Django is a full-featured, batteries included web framework. How long have you been working for again, GMT? So it follows the model template view. So Django includes an ORM for database access. Are you working at a fan company or something? I forget. Includes forms, authentication, admin interface, and much more. Django emphasizes rapid development and clean, pragmatic design. It's a great choice for building complex, data-driven websites quickly. For example, if you need to build a web application with a database, a user login, and an admin panel for content, Django provides all of that out of the box. You can literally have a basic app with create, read, update functionality in minutes by leveraging its generic views and admin. That makes sense. So Django's community is huge, and there are many plugins called Django apps for things like REST APIs, social login. Django's learning curve can be a bit steep if you've never used a large framework, but its payoff is high for large projects. It tends to be used for anything from content websites to fintech and government projects. The famous tagline, Django, the web framework for perfectionists with deadlines. In practice, Django encourages best practices, project structure, and separating concerns, and can scale well. If you anticipate a big project or just want a lot of built-in functionality, Django is a top choice. I'm gonna do a lot. I'm gonna do more research into Django as well, probably in the same video. I've never implemented I've only modified big Django applications. I've never had to write one from scratch. But yeah, I've used Django at work. And I feel like writing from scratch is how you really understand something. So that's why I always feel like I don't really understand it that well. But I've written like Express applications from scratch, so I really understand those really well. Flask is a micro web firm. Flask is more like Express. Yeah, Flask is more like Express. Request response. I've also written like in school. I've written a web server completely from scratch too. Okay. Flask philosophy is to keep the core simple but extensible. It's similar for great applications. Can you talk a little bit more about Django and what directory structure it enforces and all the things that it kind of enforces on you?
Absolutely. Django is a high-level Python web framework that promotes rapid development and clean, pragmatic design. It enforces several conventions to help developers build robust applications quickly. Directory structure. When you create a Django project, it comes with a specific directory structure, manage.py, a command line utility for various tasks. Project or project root directory contains settings, URLs, and WSGI application. App or application directories. Each app has models, views, templates, and static files. MVC pattern. Django follows the model view controller MVC pattern, but it calls it model view template MVT. Models define data structure, views handle business logic, and templates manage presentation. Dry principle. Django encourages the don't repeat yourself principle, promoting reusable components and reducing redundancy. Admin interface. It automatically generates an admin interface for managing application data, reducing the need for custom code. Django's conventions help maintain structure and consistency, making development faster and more efficient.
Cool, cool, cool. So Flask is very easy to understand. As your project grows, you can integrate the libraries you need. So it's good for quick hackathons. Despite being micro, Flask can also scale to large code bases with proper structuring. Many large systems have been built on Flask, organizing code via blueprints. In short, choose Flask when you want simplicity and flexibility and you're comfortable assembling components as needed. Flask versus Django is a common comparison. Flask gives you freedom, and Django gives you a lot of things already decided. That makes sense because then when you move from code base to code base, you already kind of know, like you don't need to ramp up. Because when you build something using Express, when it's very lightweight and very like non-opinionated, if you when you hop from company to company, that backend is gonna look so different from company to company. Whereas if you just use something like Django, it's so strict. I feel like when you move from company to company, it's kind of gonna be the same thing. Just the biz logic might be different. So what else? Yeah, it's pretty annoying. That's the one thing, bro. That's the one thing about just JavaScript and types or JavaScript in general. It's everything. It's very unopinionated. That's why the community is so large and there's so much different frameworks being spun up like every single day. What's Dash? Yeah, that's what just happens when you're working with with JavaScript and it's so unopinionated. You're like, I've never heard of Dash before. Wow. Okay. Super crack dev. Okay. Oh, use Dash for Python web apps. I never. I only use React and stuff. Bro, I just straight use the raw terminal, Paul. I just use raw Mac terminal. Yeah. Yeah, I just raw dog it too. Honestly, I never thought much about it, and then like people at work would just come by and they see me raw dogging and they just start laughing. Bro, does it for Warp? Don't you need to like log in and stuff? I almost interviewed at that company, but I didn't. But I just didn't really go through with it. Uh, Dude, the people who built Warp is sick. I think the founder worked at Google and like scaled the Google Docs or something. Like he was a founder of that. So choosing a framework. If you need to serve a full website with server rendered pages and a relational database, Django is often the top choice. With Django's ORM and templating, if you're building a single page app front end and just need an API backend, okay. Scientific computing and data. I don't really care about that, okay. Wow, this is a lot. Okay, where are we at now? Okay, we dug in a lot about Python. Let's move into MongoDB. Let's do some research on MongoDB in parallel. Okay, yo, what should I ask this thing? What do we want to learn about MongoDB? So we can talk about performance optimization techniques. We can ask it about the best practices for schema design. We could talk about comparisons with other NoSQL databases, use case and industry adoption, security features and considerations. Yo, Google guy, you're gonna learn a lot. My day job. So it's putting in together a comprehensive guide of Mongo tailored for an intermediate software engineer. It'll cover essential topics like MongoDB, CRUD operations, indexing, schema design, aggregation pipelines, performance optimizations. Okay, it's diving deep to a lot. And it's going to let us know when the research is ready. So now I've already used 3 queries. I only get 10. My friend is only letting me have 7 more. But what's it called? Let's look at this a bit. Let's finish this let's skim through this Python one real quick and let's time ourselves. We're going to probably do it for like 10 more minutes. Yo, super cracked, where are you from? Are you in Canada? Oh yeah. Super cracked dev. So we have NumPy, SciPy, Pandas, and Jupyter. Python is the leading language in scientific computing, data analysis, machine learning, and large NumPy. NumPy is the foundation of numerical computing in Python. It provides an n-dimensional array object that is optimized for fast operations and uses contiguous memory. NumPy is the fundamental package for scientific computing in Python. It includes routines, Fourier transforms. So it's vectorized. A key thing is that vectorized operations are much faster than Python loops because the heavy lifting is done in C. NumPy arrays are also the basis for other libraries. Pandas uses NumPy under the hood, and many machine learning libraries accept NumPy arrays as input. If you're doing anything math or data related, NumPy is essential. It is often used for tasks like reading data into arrays, performing element-wise math, linear algebra, and etc. My voice is. I need to maintain my voice because when we're reading all this Mongo stuff, so I'm gonna ask the AI to do some of the heavy lifting. It says right there, NumPy is used with. Can you explain the difference between NumPy, SciPy, Pandas, and Jupyter?
Sure. Each of these libraries and tools has a distinct purpose in the Python ecosystem. NumPy provides support for numerical computing in Python. It offers powerful n-dimensional array objects and functions to perform operations on these arrays, making it fundamental for scientific computing. SciPy builds on NumPy by adding modules for scientific and technical computing. It includes functions for optimization, integration, interpolation, eigenvalue problems, and more. Pandas focuses on data manipulation and analysis. It provides data structures like data frames and series to handle structured data, making tasks like cleaning, transforming, and analyzing data much more straightforward. Jupyter provides an interactive computing environment, particularly Jupyter Notebooks. It allows you to create documents that contain live code, equations, visualizations, and narrative text, making it ideal for data analysis and sharing results. These tools are often used together in data science and scientific computing.
What about TensorFlow? Does it use NumPy under the hood or no?
Yes, TensorFlow does use NumPy under the hood for various numerical operations and data handling tasks. It also offers a NumPy-like API called tfexperimental.numpy, which allows you to run NumPy code with TensorFlow's accelerated operations.
Interesting, interesting. Okay, thank you. I've never used CPy before. Oh, I hate this question. Who uses CPy? Dude, there's always sirens, man. Okay, it's just libraries. So NumPy and SciPy give MATLAB-like capabilities, and people have switched from MATLAB to Python. For experienced Pythonista, diving into SciPy docs can reveal a treasure trove of functionality that's a phone call import away. So Python is the go-to, Pandas is the go-to library for data analysis. It introduces two primary data structures, series and data frames. With label, think of Pandas as Excel or SQL tables in Python, but with much more power. Pandas provides high performance, easy to use data structures for data analysis. With data frames, you can slice, filter, group, and merge data conveniently, handling missing values and heterogeneous column types. It is extremely useful for tasks like reading CSV, Excel, and SQL data into memory, cleaning and transforming data, and doing aggregations. Dude, Google guy, I'm not gonna either confirm or deny that. Let's see. Pandas is okay, Pandas, bro, is basically simple. Pandas is just like loading in data and being able to do stuff with it instead of managing it all yourself in like arrays and stuff. Jupyter Notebook. Yeah, I've used that before. In combination, these tools often collect. Yeah. Yo, Paul, do you use a lot of pandas? I don't really use pandas, bro. So as applications become more network and distributed asynchronous programming is crucial for writing high-performance servers and clients that handle many simultaneous connections. Python has a strong support for async I/O and additionally concurrency primitives for parallelism. I've never had to use async and await in Python. Yeah, Supercrack Dev, we were looking at that earlier. But Paul, all they're gonna do in 3.14 is make it optional, but it's still gonna be around, I think. I've never used async await in my life in Python. If you're not used to it, you need to make any blocking calls, avoid or So async and await could be trickier if you're not used to it, but it can be extremely efficient for network servers. Is using async and await in Python just an alternative to the regular threading library in Python?
No, async and await are different from the regular threading library. They're used for asynchronous programming, which allows you to write non-blocking code, particularly useful for I/O-bound tasks like network requests or file operations. Async await. They enable asynchronous programming, allowing tasks to run concurrently using an event loop. This means you can handle many tasks concurrently without creating new threads. Threading. This involves running multiple threads in parallel, which is useful for CPU-bound tasks. However, Python's global interpreter lock GIL can limit true parallelism in threading. In summary, async and await are better suited for I/O-bound tasks, while threading can be used for parallelism in CPU-bound tasks.
Right. I've never had to use this async thing before. I need to look this deeper.
It's definitely worth exploring. Asynchronous programming can be a game changer for handling tasks that involve waiting for external resources. If you have any specific questions while diving into it, feel free to ask.
Yeah, GMT you can. Okay, if using threads, use the Okay. Now let's get into security best practices in Python applications. We learned a little bit about. Um, Yo, who here has used the async API? Can you explain the difference between async and threading? I just want to know like when I should use one or the other. Why can't I just use thread? Or are they like you could just like alter or yeah, you could just use whatever you want for a task. They're interchangeable basically.
Async and threading are not interchangeable. They serve different purposes and excel in different scenarios. Async I/O, ideal for I/O-bound tasks such as network operations, where you spend a lot of time waiting for responses. It uses an event loop to manage tasks concurrently without the overhead of creating multiple threads. Threading, suitable for CPU-bound tasks that require parallel execution. However, Python's GIL means only one thread can execute Python bytecodes at a time, which limits threading's effectiveness for CPU-heavy operations. Use async for tasks involving a lot of waiting, like web requests or database queries. Use threading for tasks that can benefit from running in parallel, like performing calculations.
What you just said that it doesn't like when it threads it's CPU bound is not gonna work because it's CPU bound and it's just sharing one CPU. It actually is gonna make it slower if you spin up multiple threads. Like, please, please make like, please know that there's a difference between multi-threading and multi-processing.
You're right, and thank you for pointing that out. Multithreading in Python can indeed be limited by the global interpreter lock, GIL, which means it might not be effective for CPU-bound tasks. Multiprocessing, on the other hand, involves using separate processes, each with its own Python interpreter, which can bypass the GIL and take advantage of multiple CPU cores. Multithreading, best for I/O-bound tasks that spend a lot of time waiting. It can be slower for CPU-bound tasks due to the GIL. Multiprocessing, effective for CPU-bound tasks as it uses separate processes, allowing parallel execution without the GIL limitation.
Okay,
So,
now with that information, when should I use async versus threading if they're both for optimizing I/O bound processes?
for I/O-bound tasks, you would generally use async when you need to handle many concurrent connections efficiently, such as in web servers or applications dealing with numerous network requests. Async is more scalable as it uses an event loop to manage tasks. Threading when you have a smaller number of I/O-bound tasks or need to integrate with blocking libraries that don't support async. In summary, use async for high concurrency scenarios and threading for simpler, potentially blocking tasks.
Okay, could you quickly explain the event loop? Is it similar to the JavaScript event loop?
Sure, an event loop in async programming is a mechanism that manages and dispatches events or tasks. It continuously checks for and executes tasks, such as I/O operations, in a non-blocking manner. When an I/O task is waiting, the event loop can switch to another task, optimizing resource usage. Yes, it's quite similar to the JavaScript event loop, which also handles asynchronous operations like handling events, timers, and I/O tasks. Both aim to improve concurrency without multi-threading.
So security. Security is paramount, especially in Python, especially as Python is often used for web applications, scripting, and data processing. Writing secure Python code carefully involves careful practice in multiple areas: dependency management, handling data safely, and secure configuration. Here are the key Python security best practices.
Absolutely.
Or sorry,
Security.
I didn't realize this guy was still talking. One sec. So keep your Python dependencies updated all the time. Use virtual environments and isolate dependencies. Yeah. Be cautious with third-party packages. PyPy is open. Anyone can publish. While the community and PyPy security team catch many malicious uploads, yeah, I've had to do that with like a lot of React stuff, like update from React Router v4 to React Router v6. That's a pretty common one that I've had to do at across the last two companies I worked for. Yeah, but usually you have to keep updating it a bit. But most of the time, when you're updating it, you could look at the list of all the changes that happens, and a lot of times they'll tell you exactly what you need to do in order to get to the next version. And then sometimes there's also like code mods that will modify your code so that it could like get to the next version as well auto magically. Okay. Okay, let's look at the summary. So let's look at the best practices and emerging trends. So to truly master Python beyond knowing the internals and ecosystem, one should adopt the best practices and stay aware of emerging trends. So writing Pythonic code is a trend. Embrace the idioms in Python. Use list comprehensions, generators, context managers for resource management, and follow PEP 8 style guidelines for readable code. Effective use of language features like data classes, enumerate, zip. You can make cleaner code more robust. So yeah, just write Pythonic code. Understand the different like functions that are given to you, and yeah, write code that manage that's good, that looks nice. Basically, essentially, I feel like with Python or with JavaScript, a lot of that is using like the new for each and map and stuff, and not just using like the old school for loops and stuff. No, what's that? Yeah, they're very, very similar. Okay. Using type hints and static checkers is growing. Okay. Tools like black. So use static typing adoption. As discussed, using type hints and static checkers is a growing best practice. Dude, Python is just becoming like JavaScript, I swear. showing how to use async and allows you to delegate thread pools when needed. I still need to figure out more. I never dove deep into like async and await. Alpha code. How do you deal with no enforced types? We use MyPy. Were you here when we covered MyPy? A lot of companies use MyPy. MyPy right here enforces the code. Or it's almost like TypeScript, right? So MyPy is a static type checker. It's almost like TypeScript, but it doesn't like, it's not a separate language. Essentially, you just write types in your file, and then MyPy kind of analyzes your code and just makes sure, and it gives you type errors. Yeah, MyPy kind of enforces it. So MyPy is pretty good. I haven't used it I only got introduced to it at work. It's very, very slow, but I'm gonna try to implement it in one of my side projects. Does it give compile time errors? It basically is like a compiler, but it's not changing your code or anything actually. But what it does is you can run it on your code base, and it's gonna tell you everything that's wrong with it. And a lot of times you run it in your CI, and then you can't even push code unless you solve like the type check errors. But it's not really compiling anything. It's just like static analysis. It's just looking over the files. Yeah, it's kind of its own software. Can you explain? Can you wait? Let it load.
Of course. Take your time. Let me know if there's anything specific you'd like to ask.
Yeah. Could you explain what MyPy is, and what is it written in?
Sure. MyPy is a static type checker for Python. It allows you to add type annotations to your Python code and helps catch type-related errors before runtime, improving code quality and maintainability. MyPy itself is written in Python. It's designed to integrate seamlessly with Python projects, leveraging Python's own syntax for type annotations.
Does it like read the whole your whole like project, and then it follows like references and calls and just make sure, like, how does it work internally? Just give a high level description.
Yes, MyPy analyzes your whole project to ensure type correctness. Here's a high-level overview of how it works. 1. Parsing. MyPy parses your code, reading all the files in your project, including type annotations. 2. Type inference and checking. It infers types from your code and annotations, and then checks these against function calls, variable assignments, and more to catch type errors. 3. Cross-file analysis. MyPy follows references and calls across different modules to ensure type consistency throughout the project. By doing this, it helps catch potential issues early, before runtime.
Nice. Is MyPy the most popular, and what's Pydantic?
MyPy is indeed one of the most popular static type checkers for Python. It helps catch type-related errors early by using type annotations. Pydantic, on the other hand, is a library for data validation and settings management using Python type hints. It's commonly used in frameworks like FastAPI to ensure data integrity by validating and parsing data based on defined schemas.
Yo, Lev, what's good? Yo, super crack. I think, what's it called? Pydantic is a bit different than MyPy. Yo, Lev in the building. Lev in the building. Nice to see you, bro. We're diving deep into Python, but we're almost done. Yeah, super crack what you're saying. What else? So while Python is not the fastest language, a master knows how to optimize critical section using better algorithms, leveraging better built-in functions, using list and dict comprehensions. When that's not enough, one can resort to tools like Python, Numba. Okay. Vectorized libs like Python distribution. The Python project packaging landscape is evolving. A well-rounded Pythonista should know how to create a package with setup tools or poetry. Include writing a good setup.py or py project config, specifying dependencies and publishing to PyPy. Additionally, tools like pipex allows users to install CLI Python tools in isolated environments. So, DevOps and tooling. Python is often used in automation. Knowing how to write cross-platform scripts, awareness of different file systems, how to use logging, and how to set up tests and CI. For Python, what's UV? I think poetry's the one that's getting really popular. I've seen poetry a lot. Hey, when we say Python 3.11, Python 3.14, are those new versions of the Python interpreter?
Yes, Python 3.11 and Python 3.14 refer to newer versions of the Python interpreter. Each new version typically brings improvements, new features, optimizations, and bug fixes. For example, Python 3.11 introduced performance enhancements and new language features. Keeping up with the latest versions can provide access to these improvements and new functionalities.
So if I move to 3.14, I literally have to update my whole code base. Or is 3.14 usually supports backwards compatibility, but then introduces new syntax and stuff like that.
Generally, new Python versions like 3.14 aim to maintain backward compatibility, meaning your existing code should generally run without changes. However, it's always good to check the release notes for any deprecated features or minor breaking changes. In most cases, you won't need to update your whole codebase, but it's important to test your code thoroughly with the new version. You'll also gain access to new features and improvements that can enhance your projects.
Nice. Lev, what are your thoughts on DevOps? DevOps is important, but I wouldn't. I like doing regular software engineering, honestly. Reading Python. But when you work at a startup, you have to do your own DevOps. Can you explain PEP?
PEP stands for Python Enhancement Proposal. It's a design document that provides information to the Python community or describes new features, processes, or environments for Python. PEPs are the primary mechanisms for proposing major new features, collecting community input, and documenting design decisions.
I see. Do I think it's useless and will it stick around for the long term? No, I don't think it's. I don't think it's useful. I mean, sorry, I don't think it's useless. Like as a software engineer, I don't want to worry about DevOps. I just want to, if I'm like working on product stuff, I just want to focus on building the products, and then figuring out, making sure it's getting deployed, making sure that it's running 24/7, all of the things related to just operations, I don't really want to think about that. I just want to think about product related features and product related things. So I think it helps separate concerns because the DevOps people don't really know much about the product. They just know we're gonna get, or the business logic. They just know like, okay, we have this thing and we need to just make it run, and then they just need to have it set up on the infrastructure. I think when the organization gets really big, it's good to separate those concerns. So as mentioned, PEP 703 will make GIL optional in the future. This is an emerging development that could change how we write multi-threaded Python. It may be a couple years out, but it's on the horizon. Mastering Python includes understanding these possible futures and being adaptable if and when they become a reality. Python in a GIL-less perhaps in a GIL-less Python, patterns like multi-threaded data processing will become more common than multi-processing. I mean, if they remove the GIL, wouldn't that mean let's just move away from the multi-processing library? So community resources. Finally, mastering Python is an ongoing process. It's good to know where to find answers and learn. The official Python documentation is excellent, especially the language reference and yeah. So real Python is sick. Stack Overflow obviously. And going to PyCon and stuff. Maybe I might listen to those more if I want to dive deeper into Python. I do like Python as a language. I do want to dive deeper into the language because I use it a lot. I mean, we all use it for coding. Paul, what do you use for coding? Do you use C++? The primary source for internals and best practices. The Python's the developer guide on Python's GitHub has details like yeah. So Fluent Python, an excellent book that covers writing idiomatic and effective Python. It goes to the data model, functions, objects, metaprogramming, concurrency. Fluent Python is aimed at developers who know the basics and want to write better, more Pythonic code and understand Python's features deeply. The book is highly recommended for mastering advanced language features and holy crap, we went deep into Can you give me a summary of the sections we covered in the deep? So now we have our deep research report, and I'm gonna send this over to everyone. I'm gonna post this on my GitHub and send it over on the Discord. But now we have a deep understanding of Python. Wow, that was crazy. We actually covered a lot. Hey GPT, are you able to search the web and see if people are using poetry still, or UV is more common package manager for Python? I've never heard of UV before, man.
Poetry is still widely used and popular among Python developers for its features like automatic dependency resolution and virtual environment management. It offers a user-friendly way to manage dependencies and package projects. UV is a newer tool that's gaining attention but isn't as widely adopted yet. As of now, Poetry remains a more common choice for managing Python packages.
What should I switch to using UV or should I use Poetry?
It depends on your needs and preferences. Poetry is well established, with a robust community and comprehensive features for dependency management and packaging. UV is newer and may offer some performance benefits, but it might not have the same level of support and features yet. If you're looking for a stable and well-documented tool, Poetry is a solid choice. If you're interested in experimenting with new tools and potentially better performance, UV could be worth exploring.
Okay. What about just using the old school pip install? Is that less optimal?
Pip install is still a reliable and commonly used method for managing Python packages. It's straightforward and works well for many projects, especially smaller ones or those with simpler dependency requirements. However, pip alone lacks some of the advanced features found in tools like Poetry, such as automatic dependency resolution, virtual environment management, and project scaffolding. For many use cases, pip is sufficient, but if you need more comprehensive project management, Poetry might be a better fit.
Okay, so pretend I have a large scale Python code base. Please recommend me a package manager.
For a large-scale Python codebase, Poetry is a great choice. It offers dependency management, automatically handles complex dependencies.
Okay, it looks like it wants us. It's just recommending Poetry over all those, especially if the thing is gonna get really big. Okay, I'll probably end the video after this summary, and then we'll look at maybe MongoDB is gonna be tomorrow, and we'll just dive deep into MongoDB. We'll do a live stream on that, or just Django. I think we just do one at a time to avoid overloading, because we learned so much from just this live stream. It's crazy. Um, yeah, yo, yeah, super crack dev. Like, thanks for even letting me know what UV is. But yo, I got work on Monday, bro. It's crazy. It's actually nuts. I'm actually shocked I have work. It's L's. Yeah, they don't wanna do the holiday. Maybe they observed it somewhere else. Yeah, maybe they observed it on a different day. But yo, I'm gonna send everyone like this conversation so you have it. I thought it was a holiday too, but it looks like people are working. Okay, so we dug deep into Python internals, understanding how Python works under the hood. We learned about memory management and garbage collection. CPython uses reference counting with a cyclical garbage collector. Objects have generations for efficient cleanup. Alternative Python implementations like PyPy use different strategies, but there's different Python interpreters. Python interpreters read Python code, convert it to bytecode, and run that bytecode on the Python virtual machine. And essentially, yeah, that's kind of how it works. I'm pretty much fully on site, 3 days a week. It's not 5 days a week though. I don't even know what's hybrid these days. So interpreter internals. So PyPy is faster. So Python compiles the bytecode, which the virtual machine executes. And alpha, I have an offer, but they're picking teams and stuff first. That's kind of how it works. There's a team matching, but I don't really get to choose my. They changed the process. Before you team match and you interview, but now you kind of get matched, and then they send you a final offer letter with the hiring manager that wanted you on their team, and then you don't really get to pick. So Python compiles the bytecode. only one thread can execute Python bytecode at a time due to the GIL. GIL is the bottleneck for CPU-bound tasks, using multi-processing instead of threading for parallelism. Async I/O and multi-threading still work well for, yeah. So how Python compiles and executes code. Python source code goes through parsing, AST, bytecode, and then execution. Bytecode optimizations helps performance but lacks static compilation. Okay. Metaprogramming introspection. So Python supports dynamic class creation, decorators, metaclasses, and executes and evals. Introspection tools like directory, type, and inspect enable runtime reflection. Best practice: use metaprogramming sparingly to maintain readability. Yeah, I'm hybrid then. So the ecosystem, like package management, type checking, testing frameworks, and then different web frameworks, then a bunch of the scientific. Okay. Okay, cool. Package, no-gil, DevOps. So further learning. Cool. Yeah, I think I just learned a lot. What do y'all think? Y'all learned a lot about Python or what? What did y'all like learn that you didn't see before? Or did you already know all that? That was crazy. Python goes deep, man. Yeah, MyPy is used at a lot of companies, a lot of big companies. A lot of big companies contributed to it too. Yo, I need to study compilers. Maybe I'll do deep research into compilers at some point. But yo, thanks for hopping on. I wanted to cover more, but it took 3 hours to go deep into Python, but that's okay. That's all good. Or 2.5 hours. We'll keep it chill. We'll keep it a chill study session. Won't spam it too hard. But we'll try to do more of these deep research. So if you want me to study more topics, just let me know which ones you want me to cover. But have a good night. Maybe tomorrow we'll do leak code questions or something. We'll just keep, bro. If we do this every single day, we're gonna be crazy. We're gonna learn. We're gonna be crazy at coding. But I'm gonna also talk about projects and side projects and stuff because that's important as well. But all right, good night, folks. Catch y'all in the next stream. And look out for, yeah, good night, bro. And look out for my interview or my prep tomorrow where I'm helping prep someone for a 2 Sigma. Yeah, it's gonna be crazy. There's gonna be a lot of good content coming up. I'm gonna be training up a lot of kids cause a lot of internships are coming up. So I'm gonna try to train up a lot of kids for their FANG interviews. Yeah, Paul, we got this, man. You want more quant content? Sure, sure. I mean, I'm not a quant or anything, but I'll try to find people who are interviewing for those. But alright, catch y'all in the next stream. Peace.